This is SpaceTime, Series 22, Episode 87. Coming up on SpaceTime, gamma-ray bursts reveal more of their secrets. Evidence of the missing neutron star inside Supernova 1987A. And Blobs said to be evidence for life on Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A violent explosion in a distant galaxy has broken the record for the brightest source of high-energy electromagnetic radiation in the universe. The energy was emitted by a gamma-ray burst, a brief but powerful cosmic explosion, which occurred in a galaxy some 7 billion light-years away. Gamma-ray bursts are considered the most powerful explosions in the universe since the Big Bang 13.82 billion years ago. But the new findings reported in the journal Nature show that these stellar explosions are even more powerful than previously thought. The most common type of gamma-ray burst occurs during the death throes of the universe's most massive stars, as they literally tear themselves apart after running out of fuel for core nuclear fusion. This causes the star to violently collapse inwards, crushing the core down to produce a rapidly rotating stellar mass black hole, and generating the most powerful core collapse supernova explosions. In one of these events, the surrounding gas forms an accretion disk around the black hole, with gas jets ejected perpendicular to the plane of the accretion disk, creating the gamma-ray flashes. Elementary particles are accelerated along these jets to velocities approaching the speed of light. These jets interact with the surrounding material and radiation, generating an initial pulse of gamma rays, the most energetic form of light, which typically lasts for about a minute or so. Astronomers first recognized gamma-ray bursts 46 years ago, after American military satellites, designed to detect gamma-ray emissions from clandestine Soviet Union nuclear tests in space, began spotting sudden violent explosions of gamma rays at random locations across distant parts of the sky as frequently as once a day. Now, eventually, the Pentagon realized that Moscow simply couldn't be testing so many nuclear weapons over such a vast area of space, and they called in astronomers, who quickly determined that these were actually natural cosmic phenomena rather than Soviet atomic bomb tests. Gamma-ray bursts appear in the sky without warning about once a day. A typical gamma-ray burst will release as much energy in a few seconds as the sun produces during its entire lifetime. Now, while the actual burst itself is over in just a few seconds, it generates a faint afterglow which can be observed for several minutes, a few months, or even years later. This afterglow is caused by the blast shockwave of material from the gamma-ray burst as it slams into the surrounding interstellar medium. Scientists suspect that most of the gamma rays from these afterglows originate in magnetic fields at the jet's leading edge. High-energy electrons spiraling through these fields are directly emitting the gamma rays through a mechanism called synchrotron emission. On January 14, 2019, a gamma-ray burst was detected by two of NASA's Earth-orbiting gamma-ray satellites. The Swift Space Telescope, which searches for gamma-ray bursts, and the Fermi Gamma-Ray Space Telescope, which hunts for gamma-ray sources across the sky. The gamma-ray burst was catalogued as GAB 1901-14C, and within 22 seconds its coordinates were sent to astronomers around the globe. Among them were the operators of the twin Major Atmospheric Gamma Imaging Cherenkov, or MAGIC, telescopes in the Canary Islands. The MAGIC collaboration's two 64-ton telescopes were pointed towards the gamma-ray burst within 27 seconds, and they were able to observe the burst within 50 seconds of it appearing in the sky. In the first seconds after they started observing, the MAGIC telescopes detected photons from the afterglow that clocked in at between 0.2 and 1 tera-electron volt. That's equivalent to the amount of energy released by proton collisions at the Large Hadron Collider, the world's largest atom smasher. It's the first time such high-energy radiation, 1 trillion times more energetic than visible light, has been detected from a gamma-ray burst. One of the study's authors, Dr. Gemma Anderson from the Curtin University node of the International Center for Radio Astronomy Research, says that makes this gamma-ray burst the brightest known source of tera-electron volt photons in the universe. Over 300 scientists from more than 24 observatories around the globe carried out follow-up observations of the spectacular burst using telescopes across the electromagnetic spectrum to gain as much information as possible, including exactly where the event originated and what its physical attributes were. Anderson and colleagues monitored the burst using the Australia Telescope Compact Array at Narrabri in northwestern New South Wales.
A gamma ray burst is when a very massive star dies and forms a black hole. And when this happens, they are so bright that we can observe them across the other side of the universe, and they completely outshine their home galaxy. And in that moment, when they explode, they actually produce more energy than our sun would give off during its 10 billion year lifetime. So this was a particularly exciting event to observe because it produced gamma ray light that is the most energetic or the most powerful we've ever seen from one of these events. So when we look up at the night sky, we see optical or visual light from the stars around us. However, objects in space, whether they are stars, galaxies, black holes, explosions, they actually can produce much higher energy light that we can't see, and this is X-rays and gamma rays. And while gamma ray bursts always produce gamma rays, in this particular case we saw gamma rays that were about 100 million times more energetic than what we've ever seen from these events before.
Now, catching these things is pretty difficult because they normally don't last very long, and so you need very specialised equipment to firstly spot these things and then to let everybody know what's happening.
That's right. So there's actually 2 satellites in space that are specifically designed to scan the sky and look for these bright flashes of gamma rays from these gamma ray bursts. And when they find one, they actually transmit the position down to Earth within a few seconds. And this allows other telescopes on Earth to actually rapidly respond and begin observing the event. So while they're found as these high energy events, we use telescopes on Earth that can observe across the entire electromagnetic spectrum to actually search and look for the afterglow from these events. So I was actually involved with a team that used the Australia Telescope Compact Array, which is a radio telescope, to search for the radio light coming from this event.
The Australia Telescope Compact Arrays at Narrabri in outback New South Wales.
Yeah, so the Magic collaboration, they are the ones that found the very high energy gamma rays, and they then transmitted this information to astronomers all around the world. And so astronomers all around the world, they picked their favourite telescopes in the part of the electromagnetic spectrum that they usually work in, and they observed this event. And then all of these observations from all these telescopes around the world were pulled together for us to try to understand how these very high energy gamma rays were produced.
What do we know about gamma ray bursts?
Right, yeah. So there's actually 2 main types of gamma ray bursts. There are long gamma ray bursts, and this was a long gamma ray burst. And we're fairly sure that most of these are the death of a massive star. So when a massive star goes supernova and it turns into a black hole. There's another type of gamma ray burst called a short gamma ray burst. And this is when we think 2 very dense stars known as neutron stars actually merge, and that can also produce this gamma ray burst emission.
Meanwhile, a second paper in the same issue of Nature presents observations of another gamma ray burst detected by Swift and Fermi 6 months earlier, back on July the 20th, 2018. Catalogued as GRB 180720b, this event was also very strong and lasted for about 50 seconds. Again, a relatively long duration, indicating the death of a really massive star. 10 hours after the initial alerts, the high-energy stereoscopic system HESS in Namibia pointed its 28-metre gamma-ray telescope at the location of the burst. HESS is dedicated to very high-energy gamma rays with energies up to 440 gigaelectron volts. Even more remarkable, the glow continued for more than 2 hours following the start of the observations. That means 12 hours after the initial detection. Catching this emission so long after the initial gamma-ray burst detection was both a surprise and an important new discovery. It means the very high-energy gamma radiation which has been detected not only demonstrates the presence of extremely accelerated particles in the gamma-ray bursts, but also shows that these particles still exist, or at least are created, a long time after the initial explosion. Most probably, the shockwave from this explosion is acting as a cosmic accelerator.
This is actually a really new field for gamma ray burst astronomy. So we've had 2, they're called Cherenkov telescopes. They're a special type of telescope that look specifically for these extremely, very high energy gamma rays. and both of them have found a signal from a different gamma ray burst, has detected this very high energy gamma rays. This is a fairly new field in gamma ray burst astronomy that we now have developed the technology and the techniques to the point where we can actually rapidly follow up and observe a gamma ray burst as soon as it's been detected with these Cherenkov telescopes. So we're basically entering into this new era. And the theory is we think that actually all gamma ray bursts may produce some of this very, very high energy gamma ray light. But until this point, we really haven't been able to do it. And so it's a very, very exciting discovery, and it's going to tell us more about gamma ray bursts and help us to understand how they work.
What do we think the afterglow is?
In this case, when the massive star exploded, a lot of the material turned into a black hole. But the rest of the material was actually thrown back out into space, moving at near the speed of light. And this material then collides with all the surrounding gas and dust in space. And as part of this collision, you actually get particles accelerating, and it actually produces light, or this electromagnetic radiation from the radio, optical, infrared, X-rays, and gamma rays. So it doesn't matter what the original engine was of the gamma ray burst, but it's all this material that's slamming into the surrounding gas and dust that actually produces the afterglow. And so we think that these very, very high energy gamma rays that were detected from these two gamma ray bursts is actually produced as part of the afterglow as well.
So does this tell you something about the environment around the progenitor?
Absolutely. So that's where radio observations come in. So as I said, I was part of a team that observed this event using the Australia Telescope Compact Array, which is a radio telescope. Now, while radio light is the least energetic, it actually traces the very fastest moving part of the explosion, the very fastest moving part of the ejecta as it begins to interact with the surrounding gas and dust. And it's this radio light that actually tells us about the environment. It tells us about the density, about what's out there, and therefore perhaps the evolution of the progenitor star that exploded. So it tells us about how windy these stars were, the amount of gas and dust that the star gave off during its lifetime. And so we can actually use this radio light to help us to understand where the very, very high energy gamma ray light came from.
That's Dr. Gemma Anderson from the Curtin University node of the International Centre for Radio Astronomy Research. You're listening to Space Time. I'm Stuart Gary. Astronomers have finally uncovered evidence of the missing neutron star that's been hidden at the heart of Supernova 1987A for more than 30 years. Well, as we mentioned on the show last week, Supernova 1987A marked the explosive death of a spectral type B3 blue supergiant star called Sanderluke 69202 on the outskirts of the Tarantula Nebula, 168,000 light-years away in the Large Magellanic Cloud, one of the nearest dwarf galaxies orbiting the Milky Way. The progenitor star is estimated to have been around 20 times more massive than our Sun. Light from the supernova reached Earth in February 1987, making it the closest observed supernova since the invention of the telescope, and Kepler's supernova, which was visible from Earth in 1604. It's given modern astronomers the opportunity to study a core collapse Type II supernova in unprecedented detail, gleaning many new insights into stellar evolution. Based on the mass of the progenitor star, Supernova 1987A should have produced a superdense compact stellar corpse called a neutron star. And the neutrino data suggests that a compact object did form at the star's core. However, despite decades of searching, astronomers have been unable to find it, until now, concealed by a thick cloud of cosmic dust. The supernova explosion, which took place at the end of the star's life, resulted in huge amounts of gas with temperatures of well over 1 million degrees. But as the gas began to quickly cool down to below 0 degrees Celsius, some of the gas condensed into solid grains of dust. And the presence of this thick cloud of dust has long been the main explanation as to why the missing neutron star has not been observed. But some astronomers were pretty skeptical about all this, and they began questioning as to whether their understanding of stellar life cycles was correct. The discovery, reported in the Astrophysical Journal, is based on observations of a patch of the dust cloud that appears a little bit brighter than its surroundings, and which happens to match the exact suspected location of the neutron star. The study's lead author, Dr. Phil Sagan from Cardiff University, says the light from the neutron star is being absorbed by the dust that surrounds it, making that part of the cloud shine in sub-millimetre wavelengths. So, the authors used ALMA, the Atacama Large Millimetre Submillimetre Array Telescope in the Atacama High Desert of northern Chile, to search that particular patch of the supernova dust cloud for the sub-millimetre glow. The new findings will enable astronomers to better understand how massive stars end their lives, leaving behind the universe's densest objects, neutron stars, and their even denser counterparts, black holes. And now that astronomers have pinpointed the location of the neutron star, all they need do is wait for the dust cloud to dissipate enough to actually see the underlying neutron star directly for the first time. This is SpaceTime, still to come. SpaceX's new interplanetary experimental Starship has experienced a slight setback after a spectacular failure during a tank pressurisation test. And later in the science report, atmospheric carbon dioxide levels have reached a new global peak of 407.8 parts per million. All that and more still to come on SpaceTime. As scientists continue their research to determine whether life has ever or could ever have existed on Mars, an Ohio University professor claims his analysis of images from NASA's Mars rovers have already shown evidence of Martian life. Emeritus Professor William Ramosa claims the images he's seen clearly show the fossilized remains of insect and reptile-like creatures. Ramosa, who specializes in arbovirology and general medical entomology, has spent several years studying photographs from the red planet. He says he's found numerous examples of insect-like forms structured very similar to bees, as well as reptile-like forms, both as fossils and living creatures. However, others claim the blurry images he's seeing are nothing more than pareidolia, the psychological phenomenon which causes people to see patterns in random objects, such as faces in clouds, or Jesus in the wood-grain light and shadow of a wall. Ramos has been an entomology professor at Ohio University for 45 years, and he co-founded the university's Tropical Diseases Institute. He also spent nearly 20 years as a visiting vector-borne disease researcher at the U.S. Army Medical Research Institute of Infectious Diseases, and he's both authored and co-authored at least 4 editions of the widely used textbook, The Science of Entomology. Ramosa presented his findings to the National Meeting of the Entomological Society of America in St. Louis, Missouri. He insists there has been and still is life on Mars, saying the images he studied clearly show apparent diversity among Martian insect-like fauna, which display many features similar to Terran insects that are interpreted as advanced groups. For example, the presence of wings, wing flexions, agile gliding flight, and variously structured leg segments. Ramosa says that while the Martian rovers have been looking for indicators of organic activity, there are numerous images which clearly depict insect and reptile-like forms. Problem is, his best evidence comes in the form of, somewhat blurry images, which he insists shows arthropod-like body segments, along with legs, antennae and wings, which can be picked out from the surrounding area. And he says one image shows what appears to be an insect in a steep dive before pulling up just before hitting the ground. Ramosa says the images were carefully studied while varying photographic parameters such as brightness, contrast, saturation, inversion, and so on. He says no content was added or removed. The criteria used by Ramosa in his research included dramatic departure from the surroundings, clarity of form, body symmetry, segmentation of body parts, repeating form, skeletal remains, and the observation of forms in close proximity to one another. Particular postures, evidence of motion, flight, apparent interaction as suggested by relative positions, and shiny eyes were all taken to be consistent with the presence of living forms. Ramosa says that once a clear image of a given form was identified and described, it was useful in facilitating the recognition of other less clear but nonetheless valid images of the same basic form. As for me, I've looked at the images as well, but to me, they're just blurry blobs. This is SpaceTime. Still to come. A new study finds that parents who smoke dope are likely to have kids that wind up smoking, drinking, doing drugs as well. All that and much more still to come on SpaceTime. SpaceX's new interplanetary experimental Starship has experienced a slight setback after spectacularly failing a tank pressurization test. The vehicle, known as the Mark I prototype, was being loaded with cryogenic liquid oxygen when a forward tank erupted along a world line, blowing an upper bulkhead 100 meters into the sky and badly damaging the spacecraft which was sitting on its Texas test stand. The vehicle, which was slated to undertake a practice test flight to an altitude of 65,000 feet or 20 kilometers in coming weeks, will instead now be retired. Attention will now be focused on a second prototype called the Mark II, which is being built in Florida, and on a third prototype, the Mark III, which is being built in Texas and will be capable of orbital flight. Originally called the BFR or Big Falcon rocket, well, we think the F stood for Falcon, Starship is the culmination of SpaceX boss Elon Musk's dream to develop a fully reusable super heavy lift spacecraft capable of carrying 150 tons of people and cargo into orbit and 100 tons on missions to the Moon, Mars, and interplanetary journeys across the solar system. Technically, Starship is the upper stage of what is a two-stage launch system. The 230-ton first stage, called Super Heavy, will be 68 metres long, 9 metres in diameter, and constructed out of glistening stainless steel. It'll be powered by 37 liquid methane and oxygen-propelled Raptor rocket engines, producing some 72 meganewtons or 16 million pounds of thrust. The 120-ton upper or Starship stage will be 50 metres long, also 9 metres in diameter and constructed out of stainless steel, and be powered by 6 liquid methane and oxygen propellant Raptor engines, 3 atmospheric and 3 vacuum, delivering approximately 12,000 kilonewtons or 2,600,000 pounds of thrust. A refueling tanker and satellite payload delivery version of the upper stage will also be produced. Eventually, SpaceX plans on using the Starship Super Heavy launch system to replace the company's existing Falcon 9 Dragon, Crew Dragon 2 and Falcon Heavy launch systems during the early 2020s. Meanwhile, SpaceX has carried out a successful test firing of its Crew Dragon 2 spacecraft's 8 Super Draco abort engines at Cape Canaveral. The latest ground test followed a similar attempt back in April which failed, destroying the spacecraft in a massive explosion. It seems a faulty check valve inside the Super Draco's propulsion system allowed nitrogen tetroxide oxidizer to enter high-pressure helium tubes during ground processing before the attempted static fire test. The helium system is used to quickly pressurize the propulsion system, allowing the Super Draco thrusters to fire up during a launch emergency. When the abort system began pressurizing during the April test, nitrogen tetroxide, which had leaked into the helium pressurization system, was driven back into the check valve, destroying the titanium check valve and causing the explosion. This successful test now paves the way for next month's high-altitude in-flight abort test, which will see the Crew Dragon 2 capsule rocketed away from its Falcon 9 launch vehicle during ascent at about max Q, the very point of maximum dynamic pressure on the vehicle. If that goes well, the Crew Dragon 2 will undertake its first manned flight to the space station, now slated for the first half of 2020. And time now to take a brief look at some of the other stories making news in science this week with a science report. Levels of carbon dioxide in the atmosphere have reached a new global peak of 407.8 parts per million during 2018. That's up from 405.5 parts per million the previous year. The findings by the World Meteorological Organization also confirmed that the increase in CO2 levels between 2017 and 2018 was above the average growth rate over the last decade. The report says concentrations of 2 other major greenhouse gases, methane and nitrous oxide, also surged by higher amounts than during the past decade. The findings show that no matter how well nations cutting greenhouse gas emissions comply with the Paris agreements, the massive increases in greenhouse gas pollution being pumped out by China and India are continuing to completely destroy that effort. A new study has found that providing free HIV self-test kits to men who have sex with other men may be a useful way to detect infections that may otherwise go unnoticed until much later. Researchers recruited 2,665 men with an average age of 30 and sent the testing group 4 kits which they could use at home over the course of 12 months. The self-testing group did check themselves more frequently, with 12 infections identified in the first 3 months compared to just 2 in the control group. A report in the Journal of the American Medical Association suggests that giving men free home testing kits increases awareness and helps prevent HIV transmission among the LGBTIQ community. New fossils of an ancient-legged snake has shed light on the origin of the slithering reptiles. The fossil discoveries made by Flinders University provides details about how the flexible skulls of snakes evolved from their lizard ancestors. And it also analyses the snake family tree, showing how they possessed hind legs during the first 70 million years of evolution. Scientists reached their conclusions after performing high-resolution CT scanning and light microscopy of the preserved skulls of a legged snake known as nagesh. Snakes are famously legless, but then again, so are many lizards. What truly sets snakes apart is their highly mobile skull, which allows them to swallow large prey items. A report in the journal Science Advances claims nagesh is the most complete three-dimensionally preserved skull of any ancient snake, and it's providing new insights into how the flexible skulls of snakes evolved from their lizard ancestors. It has some, but not all of the flexible joints found in modern snakes. Its middle ear is an intermediate between that of lizards and living snakes, and unlike all living snakes, it retains a well-developed cheekbone, which again is reminiscent of that of lizards. Well, you may well be telling your kids to do as you say, not as you do. But US researchers have found an association between parents that smoke pot and an increased risk of their kids smoking tobacco or marijuana, drinking, or taking opioids. A report in the Journal of the American Medical Association looked at around 25,000 parent-child pairs living in the same house. They found stoner parents wound up having kids who also ended up smoking, drinking, or getting hammered. The National Seniors Lobby has just been added to the list of nominations for this year's Australian Skeptics Bent Spoon Award. Named in honour of Uri Geller, who claimed he could bend spoons with just the power of his mind, the Bent Spoon Award is presented annually to the perpetrator of the most preposterous piece of paranormal pseudoscientific piffle of the past year. The National Seniors Lobby Group have been nominated for promoting pseudo-medicine to its membership. Tim Mendham from Australian Skeptics says they join a prestigious lineup of other nominees, including the ABC, which has been nominated twice, the SBS, Channel 9, several universities, and ALDI.
The National Seniors Australia, the lobby group, as I said, they claim to be the independent voice of older Australians. So it's not a medical group or anything like that. It is a lobby group that sort of talks to governments, etc., to try and speak on behalf of older people. They sent out a leaflet to all its membership promoting a particular company with special deals on vitamins and supplements, which the NSA, the National Seniors Australia, described as their wide range of affordable quality vitamins and supplements and natural living products. So this was totally unsolicited, but it came with the imprimatur of this group, which is sort of regards itself, and a lot of people take it seriously, promoting ancient healing herbs, traditional Chinese medicine, Ayurvedic medicine, which is the Indian style of thing, all that sort of stuff going on and on and on.
So it's a mixture of vitamins and minerals plus a bunch of hokum as well.
Absolutely, absolutely. And going out under the imprimatur of this National Seniors group is a major concern, considering it's a target audience, it's a vulnerable audience as well. So it's that really sort of warranted a Bent Spoon nomination for them.
Are they being paid by the company that's pushing these products?
It's a moot point, actually. If they are, if they're just doing it. It's supposed to be they're acting in partnership to promote this product, so I don't know if they're getting a kickback or not. But certainly, yeah, the idea is that they're offering cheap vitamins, etc.
There's probably nothing wrong with the vitamins and minerals side of it. That's fine. But it's the other stuff,
PCM,
which is the issue.
Well, that's right. And sort of, you get into one of these things, and if you regard them as gateway drugs or something like that, or gateway health treatments, introduce traditional Chinese medicine and Ayurvedic medicine, for which it's very, very serious concerns about these, not just as to how effective they are, but to potentially how dangerous they might be as well.
And
not to mention what traditional Chinese,
but what it's doing to the environment as well.
Absolutely, the wildlife, etc. So it's a major, major problem with Chinese medicine that it's using up a lot of rare animals for absolutely no purpose, no benefit.
That's Tim Mendham from Australian Skeptics. The Bent Spoon Award winner will be announced next month at Skepticon. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimeWithStuartGary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.